I can play around with that also in one of our projects and see. Otherwise,
Mm,
I mean, they always I see what, I see where the wall is. Um, it just looked different, so that's why I brought up the question.
yeah. So, uh, well, for like anyone else, any other questions regarding the end display? Because I know if you guys are like, if some people is new to end display, it's a whole ride, to be honest, to get
Yeah, it
like to
is.
understand end display. It's something
Actually,
just
when in display fails, sometimes we even do a couple of tricks with the viewport directly with the preview or whatnot.
yeah.
Film Riot guys always also do that if they have problems with in display. So there are several tricks to to make it work.
Yeah, and this play, to be honest, like it's great. It works great, but uh, at some productions, at some point, sometimes it just crashes or it just doesn't work, or even like the options they have, like freeze the viewport, they mostly don't work or they break something. I don't even remember where the option was, but um, yeah, like all these options right here, like adapt resolution and freeze viewport and stuff like that. Sometimes we just avoid them completely because they just break something, or they just don't work. Depending even on the like freeze viewport right here, depending even on the Unreal Engine version you are working on. In the 5.5 version, if you activate freeze viewport, sometimes or most of the time it just doesn't work. It doesn't, and display doesn't render out. Um, and in 5.2 it was working. 5.4 I believe it was working too. And at some point they just break it. And yeah, it's when we try to talk when we try to talk with like guys in big studios, like we asks them out like, hey guys, how do you manage like this problem with end display or this this book or whatever. At some point they just tell us, oh, we just tell the programmers that and they fix it, they pretty much, yeah, because they got a whole team of programmers just ready to just get
Yeah,
into code,
that
in
happens.
the source code. And
Yeah, Mike laughed because he knows that, and actually, ILM did their own version of Unreal. They have their own engine now, but
or
they know they
well,
have a army of programmers to help. The virtual production guys inside ILM. So, right, Mike?
yeah, that's what they have told us so far. But for us, because we're more like indie or double A productions, that's not a possibility, like at all. So yeah,
Okay, so how about let's begin?
yeah, let's go back. So today we're gonna see pretty much the virtual art department in general. Uh, we're gonna focus today in 3D modeling and in scanning, 3D scanning, photogrammetry, Gaussian splatting, stuff like that. Tomorrow, we're going to see all the techniques we have in the studio right now when it comes to content creation. Tomorrow, we're going to see like AI content creation, 2D plates, 3D AI, image to 3D, stuff like that. But today, we're just going to focus on the traditional workflows for 3D modeling and kind of new ones with Nanite and Lumen. And we're going to just overall do a overall see overview of like 3D scanning in general. So yeah, let's start with BAT, the virtual art department. So uh, the work of the BAT team is pretty much to bring these ideas of the client to life. Like the client comes in, They usually just sometimes this actual like stuff that the clients have, different clients have sent us in the past. The client comes in and they pretty much I don't know, show us a reference like this image, or they even send us like a video of a movie scene or something. And we usually ask we usually ask for the storyboard at least, and a mood board or something, so we can get a grasp of what style they're really looking for. The more references we got, the more the better, right? The easier it is to get like a grasp of what the client wants for the background, because even if you're doing like photorealistic stuff, there's different styles and art directions and decisions you're gonna make. So yeah, these are all real examples we have got in the past for different. For example, the Chunkin Express clip right here was actually one of the references for Train Dreams, and they pretty much send us the Chunkin Express video. They send us a picture of the forest they were shooting on, and that was pretty much it. That was the whole reference, and we had to work on that. And yeah, and other times they just pretty much send us a single picture, and that's your whole references, and they tell you like, oh, it's supposed to be New York in the 1970s or something like that. And you gotta look for the references yourself. You gotta look for the time being. If they tell you, oh, it's something in the 70s, you gotta look for 70s architecture stuff, or like right here in the museum references, you gotta look for all the details, like the columns, how it looks, all the photos, info, measurements you can get. Everything helps when it comes to bad department. So yeah, this is the first step. First step is like we get like a mood board, an idea, I don't know, something, a storyboard, something to really for us to really look for images and references. In this case, the point was to do something like El Museo del Prado in Spain, and we started looking right for the column references, references of the hallway, references of the textures, even in the, like if they have like a concrete floor, we start looking for those types of concrete textures, or marble or stuff like that, right? And we also start looking into the history of the museum, or images of the artwork that is displayed right there. Everything helps. We even get to the point we start like looking for images in like Google Maps, in the reviews or anything. Just really helps to really ground you on the idea of what are you supposed to make. So that's usually the first step, gather references every time. And this is the same, at least for us, when it comes to like video game productions. Every time a artist wants to start like a asset or 3D modeling something, whatever, uh, the first thing they should do is to start gathering references, especially if you're trying to do photorealistic, like get photorealistic results. The best thing you can do is to actually look at real images. That way you have like good texture references. You get a really ground comprehension of like how this, I don't know, how this concrete floor reflects the light, or how it looks in a sunny day. All those kind of things really help out to ground you on the idea of what you are making. So yeah, the first thing we do is like we gather the references. Um, then we pretty much decide what will be like the workflows we're going to use for our environment, or the content. For example, if the client comes in and the shot they're going to make is it's not, they're not going to move the camera or anything. We are most likely going to go with like 2D plates. They can be 2D plates, like actual taken in real life. They can be AI generated. We're gonna talk about them in detail tomorrow. Or we decide, okay, the client has the time, has the money, and the client also wants really integrate details, and like they really want like a special setting, like something specific. For example, I believe like in Star Wars, you gotta make the assets, right? You're making sci-fi assets that don't really exist. So there's not really like a library you can go into. I mean, unless they have like something in-house, really. I don't think there's a library online you can just go into and, yeah, let me take these Tatooine assets or whatever it is, right? So when the client really has the budget, the time, or and wants something really specific, we go to 3D modeling, the traditional workflows. When we really want like photorealistic results in the best way possible, and we have the location they want on or reach, if the location is something we can go to another city in the next state, or a city, or in the same city or close by, we can just decide it's easier for us to just go to the place and scan the place. Or maybe they just really want like a something simple. Maybe they want I don't know, New York background. There's a lot of city landscape 3D backgrounds already in Unreal Engine in Epic's marketplace. Sorry, Fab Marketplace. That's the new name. So yeah, if they want something really generic, we can just go into one of the thousands of libraries online and just download the assets, right? um, that's one part. For Train Dreams we did like actually actually, now that I think of, for Train Dreams we pretty much did all of these options except for the AI generated one that didn't exist at the time. That was like 2 3 years ago. It wasn't good enough. But we pretty much did modeling, 3D scanning, kit bash, 2D plates, and we pretty much did the solution with all the techniques available for that production. So yeah, in this step, we pretty much decide what solutions we're gonna do. Um, so yeah, we pretty much start blocking out. This is already kind of advanced, but you get the rough idea of the place. You start seeing like the scale of things. If you're doing photorealistic stuff, doesn't matter the technique, you gotta have the measurements right. If the measurements are not correct, your stuff, even if you have like the best textures, or even if you have like the best lighting, the best computer, the best rendering, or Lumen or Nanite or whatever new scanning technique, even if you scan the stuff, if you got the scales wrong, something is going to most likely look off. Something's going to look weird. There's everything needs their real life scale, right? So it doesn't look weird or uncanny. So yeah, this is the first step. In this step, we already sent stuff to the clients. We already like show them the rough pictures, because they gotta have like this rough idea that. And in this step, you barely did any modeling so far. So if the client wants a major change, they can do it right away, because you haven't really worked everything down to the last detail. So you gotta like step back a little bit, and you need to get feedback. So that way you can decide, okay, this is going to be pretty much the shot I want, right? You don't need to make any major changes, or if you do, well, maybe it's okay, because you are in the first steps. Then we start doing the medium medium poly detail, we start getting into the ornaments, the architecture, the style, and the details. And then we even give it a like a rough scope. Let me. Oh, sorry. Oh, right there. So in this point of the modeling workflow, we pretty much get into the details. This is just a Blender example I found online, but this is pretty much what we did for or some of the assets in the museum we did. Um, yeah, you don't have to worry about anything in this step, just about getting things looking great, photorealistic, getting what the client wants, and just getting into like every single detail you want. So if you can see, like, it takes like hours to. There's multiple techniques for this. You can do subdivision workflow. You can do sculpting. There's people that do everything in sculpting. There's people that do everything in subdivision workflows. We do both. We pretty much do hard surface subdivision modeling. We also do a sculpting. Like we most of the times we do a mix of techniques of subdivision and sculpting workflows. We use mainly Blender and ZBrush for this. You can use Maya, you can use 3D Max, you can even use, I don't know, Modo, you can use Lightwave or Cinema 4D, whatever software it works for you, it's fine. So yeah, after that, after we got our model ready, we pretty much start texturing, right? For this part, specifically, we need all those texture references, all those material references right away. So that way, we can start texturing. For texturing, we can do it in Blender, Substance Painter, Substance Designer. You can do it in, I don't know, in 3D Max if you want, or in Marmoset Toolback. To be honest, everything works as long as the result is fine. Whatever program you use, it's good. This is Substance Painter. Substance Painter, I think it's the standard we use at the studio. It's the most used texturing software we use. It's the fastest one for us so far. It's not that expensive, right? And it's great. It's great. You can use Photoshop brushes in here. They got like a lot of smart materials ready, so you can throw it in at any time. So yeah, it's for us is the standard when it comes to texturing. But yeah, you can use Marmoset Toolback if you want. This is Marmoset Toolback right here. So if that works for you, and we have seen some people that even like in Blender they texture and get like really photorealistic detailed results. So yeah, whatever works for you for texturing or and modeling, that works. So yeah, after that, oh sorry. So yeah, after that, after texturing, we pretty much export all the assets, you know, to Unreal Engine. We pretty much start exporting everything since we start doing the blockout at the beginning, but we start, iterating and updating the models depending on the client changes and depending on all the detail that is needed for the production. So yeah, we pretty much import all the textures, all the assets into Unreal Engine. Depending on the programs you use, it's going to be the like the workflow you're going to use for this. If you're using Substance Painter, there's already like some export options from Substance to Unreal Engine. If you're using Maya or 3D Max or Blender, they even have like a one-click export from almost any program into Unreal Engine, like one-click export. And yeah, there's plenty of solutions for like exporting the assets into Unreal Engine. You can throw in the FBX. You can use a plugin to do it like automatically for you, or you can do it manually, whatever it works for you. Um, so yeah, after that we iterate. This is not the final render. We start iterating and throwing assets and throwing and working on it slowly. In this case, the museum took us like a month, but it was like we were like three people working on it, and we were not doing it full time. We were just slowly working on it, and then we get here. This is the final renders we did for the museum, and we pretty much go from. Let me go back a little bit. Something rough like this, a blockout, a gray boxing blockout like this, to getting the details done, to doing all the sculpting, texturing, and we get here and we start working on the details, getting the right floor for the environment, and getting the questions from the clients, and getting everything done. And this is the final render right here. This is how we ended up at the end. And then that project was pretty much, you can see the integrate details of that we did with sculpting on some of the status over here. We actually replicated some of the real life status of the museum and digitally. We don't live near Spain in the Museo El Prado, so we pretty much took references and we work over that. So we could get like the best 101 replica of some of the assets, right? And yeah, that project was presented at the last year NAP show 2025. We showcased the museum right there. We have showcases the museum in all sorts of expos, and yeah, it got showcased in NAP. So if you guys go to NAP, we pretty much go every year. It's a pretty good expo for new technologies. So yeah, that was the final result for the museum we did. And I don't know if let's see a quick overview of like a speed level design, a time lapse. This is basically what we do. Like every time we do a blockout to get the sense of scale and position of everything, we just throw in some blocks. That's pretty much the first thing we do. We don't care about details at this stage. Then we start getting when we get like the composition, the shot, the lighting as we want it. We start doing the high details like in sculpting and ZBrush. Then we start doing texturing. You can do a lot of the texturing in Unreal Engine if you want. Also, they got a lot of texture libraries already in Unreal Engine. You got Quixel Megascans, which is great. And yeah, we start just adding detail and getting and working on the light, and every asset gets multiple iterations at the same time. And yeah, we pretty much start working and working, adding detail. This process can take from one day if you already got all the assets like here. Like if you already got the library going on, you can throw it in with kit bashing and pretty much get it done quickly. But if you're doing like everything from the ground up, like all the assets, all the textures, it can take you weeks or even months, depending on the on how big the team you're working on. So yeah, I don't know if you guys have like any questions for this like part so far. No questions, guys.
I'd like just to make a comment that if you go to Fab uh, twice a month, they have free assets, and you know it doesn't. You don't have to download them right away. You have your Unreal Engine, Epic Games login, and you can start building your library. And you know those projects are you can rebuild them as you want, or just import those assets into new projects. And it's a great way to get started. And all those new textures, digital assets. It's a great way to like start building that stuff up so that you have resources and not everything's being modeled from scratch or scanned.
Yeah, yeah. Fab is amazing. I have a good friend that's a executive at Fab, and she's great.
Sorry, I didn't hear the question. It kicked me out.
No,
So
no, it
yeah.
was it was just a comment, Sebastian. Sorry about that. That Fab gives away each month some of the assets, so it's really
Yeah.
it's very useful to of course, you know, once in a while to get into the Fab platform to check out what's new.
Yeah. The Fab library is great. We pretty much use it quite a lot. I think for like most productions, that's pretty much where all of our most of our assets come from. Quixel Megascans. We also buy a lot of assets from all the providers in Fab, Scans Factory, and I don't remember the other names, but yeah, Scans Factory. There's some guys called Maui also that do some great assetting, and yeah, we pretty much use them in all the projects we can. And we also got already, after like 2 3 years of working for like a lot of projects, we get like our own library pretty much. We already got museum assets. Already got a lot of rocks too. We already got a lot of like trees and whatnot. We already got also like some airport assets. So after some time, we also start getting our own library assets. But yeah, I don't know if you guys have like any question, extras, or something, any doubt, something.
Okay, just I have a question. Can you, Mikey, tell us a little bit more about Origin Track? I'm just curious, and it might be useful for the guys actually.
Yeah, so Origin Track is a company that I just started with some partners. We opened last month. We have a small little R&D space in North Hollywood. We're currently building that out, so it's mostly just Amazon boxes everywhere. Um, but our goal and our initiative is, as we're learning from this, virtual production is hard, and we are. My prediction is that studios, instead of having a full team of everyone that you need for virtual production, instead of having a full staff, there's going to be certain roles that obviously need to be staffed, but then there's going to be certain roles like camera tracking that is a contract service. A studio doesn't necessarily need a camera tracking specialist there every single day because if you're not in production, then maybe it's just like a set and forget it type of system, but you don't necessarily need that one person there every day. So our goal is that when a studio goes in production and they need to ramp up their staff because it's a larger production, maybe there's multiple cameras coming in, um, they can reach out to Origin Track and we can be a production partner for studios to our primary function is to focus on camera tracking, but whatever a studio needs, we can definitely be their partner in crime on production. And then on top of that, camera tracking has always kind of been an afterthought when it comes to virtual production. And when a studio is building out their system, folks are a lot of funding and a lot of effort and brain power is going towards, okay, what panels do we need? What's the pixel pitch? What GPUs do we need? Do we have a server room? Are we going to do a server room? And then typically one day someone says, oh yeah, we need to do camera tracking. Let me Google camera tracking. Oh, there's really only hardware providers and software providers online, and there's not really much of a community. There's not really much of a forum or a resource that a studio can go to and really dissect all of the solutions that are out there and to really find exactly what they need. Not every project needs a full Vicon system, but not every project, maybe a project does need that. But maybe a project doesn't need that. And so, maybe a Stipe system will suffice. Maybe a MOSA system will suffice. Also, a lot of times, training. Sometimes the person who was trained on your team isn't necessarily there or available, or maybe they moved on to a different studio and they were the person who knew about camera tracking. Okay, well, let's call Origin Track and we can come in, help train your team. We can help consult for you, like in the bidding process with the client. What we were talking about earlier with all the content, maybe the content that this production requires is 2D. Maybe it's 2.5D. Maybe it is full 3D. And having someone there on your team who understands camera tracking can help the bid process, help your client understand why does this need to be 2.5D? Why do you need camera tracking? If you don't have camera tracking, how is this going to break and why does it not look good? So it's all things camera tracking.
Great. Thank you very much. Thank you very much.
Yeah, absolutely.
So
Thank you.
I think, Sebastian, we can keep going.
Yeah, that actually sounds like a good idea, because tracking is like this big monster in
Yeah.
productions. Yeah, it's just...
I like to call it camera tracking is the tires of a car.
Yeah.
You don't really think about your tires until you have a flat, and now the car isn't moving at all. And that's kind of the thing with camera tracking is if it's working, no one's talking about it or thinking about it. But the moment that it stops working, the entire everything
everyone
breaks.
knows.
Yeah.
Well,
And then with that analogy, like if it's raining outside and you put slick tires on, your car is going to be in the wall. So, you have to put the right tires on for the right conditions. And that's a nice little metaphor for using the right camera tracking for the right project.
yeah, something we had like experience on is that, for example, one of the problems of using like a basic HTC like vibe tracker system, like the basic one, like less than $1,000, is that if someone moves one of the base stations, your 0 point just basically goes off. You lose it completely. You gotta recalibrate manually again. So every time we get that happening on production, everyone, even the grip guys, everyone just points their head towards the guy in the brain bar, and like everyone just like at the same time they just point their head at the poor tracking guy once again, and it's just pretty funny at some point. But yeah, it's a hell of a thing.
Yeah, I mean, when you get into when you're bidding, when you're doing demos or you're doing lighting or any prep or anything like that, and it's just the virtual production team on stage, you kind of all have an idea of how everything works and what to touch and what not to touch. But then on a production day, throw 20 people, throw 40 people, throw 100 people into that space. Unfortunately, even if it's not, a general rule is if it's not yours, don't touch it when you're on set, because you might hurt yourself or you might break something. But things happen. People
Yeah,
move a tripod, people move a base station. Maybe
yeah,
it's in their way.
yeah,
Like,
yeah.
no, the DP told me to put a light here, so move your base station. Um, and they were just like, all right. And that's the other reason why, because like sometimes camera tracking can just get handed off to the UE generalists, and they have so much work that they have to do on the day, but in production, camera tracking now becomes a very active, a very proactive type of technology that you have to deal with so that you can survive your day.
Yeah,
And the Unreal artist has 20 other billing things to do. So having a dedicated person to just say, okay, great. Oh, we have to move the base station, or oh, I now have to go talk to the first AC because they're changing the camera from a dolly shot into studio mode, and now it's going on the crane, and we have to move our equipment, off
yeah.
our GAC off the camera. Well, have the camera tracking specialist go deal with it, not the UE person, because they're probably getting notes from the gaffer right now on the next setup. So
Yeah, that happens a lot. Even in like simple indie productions of like just 1 day shootings, like even like the simple stuff, I'll always ask like for it to be like two people at least. The guy in Unreal Engine, in the bad part, and the guy in like just the tracking, just watching out for the base stations, pretty much.
mhm. Yeah, and then also that person is now boots on the floor. They're now kind of what I was talking about yesterday about that people aspect is that now a camera tracking specialist can be on set. They can be the eyes and ears for the brain bar. They can say, "Oh, hey, remember that shot that we were going to be looking this way? Well, they said we're never going to look this way. Well, guess what's happening? We're now going to start looking this way, and we haven't done any color correction over there, or maybe an asset was kind of fudgy and we didn't really like it, but we were told that we're never going to look that way. Well, now we are. So yeah, having boots on the ground, that person in the volume. Um, yes, it can be the virtual production supervisor, but having additional eyes and ears is more beneficial. And it's just keeping pace with production. Production is very fast, and sometimes virtual production uh, doesn't care how fast you're going. So you got to be proactive and work as a team.
Yeah. Uh, sorry, the stream fell because actually the light went out, guys. Um, yeah, just right now, and they're not coming back. It seems. Um, I am data right now. Phone data. Let me.
Do
Let's
you want
let's do
me?
the next thing. Yeah, yeah. I think you can share the screen, Gabriel.
I will. I
For
will ask Luis Angel. Are you there, Luis Angel? Can you help us with that?
Yeah, someone just to share the screen for the slides, and I can keep talking with data. It's fine. Yeah.
Yeah, sure.
Okay. Thanks a lot. Let me send you, Luis, the
Appreciate it. Thank you, guys.
the yeah. Let me send you guys the presentation so we don't stop with this. Yeah, just give me a moment. Yeah, just the lights went out, and when they don't come back, like in like 5 seconds, I don't know. Maybe someone just crashed onto a electric post or something.
Happens.
That is very common. That's how my sister, during the California fires, that's actually how her community caught on fire.
Oh,
Yeah, it was through like a fuse of transformer that was hit.
Wow.
Yeah, so it's pretty common.
Mhm.
More often than you think. While we're waiting for this, do these slides usually get shared before class or before session?
yeah, we can share them. No problem. Yeah,
Yeah, that'd be cool. Thank you.
yeah. We always send like the whole recording of the web of the class, and yeah, we can also attach the slides.
Station lights, of course.
Thank you, thank you.
I got the. Let me send it. I'm about to send it to you, Luis.
Thank you guys for your patience. Thank you.
This reminds me of your documentary on train dreams, and everything just comes through at the last moment perfectly.
Murphy's Law is the name of
Yeah.
it.
I already sent you, Luis, in WhatsApp the presentation slides.
In what page, Sebastian?
I don't know the number. Just keep going. Just keep going and. Oh, you pass it on already? Yeah. Sorry. It's like in the questions, right there.
Okay.
Yeah, the next one. Yeah.
Ay.
Okay. Yeah, click on presentación de diapositiva. Ahí. Yeah, right
Okay.
there. Okay. Thank you. Thanks a lot, guys. So, yeah, now let's talk about the legacy pipeline. Why do I call it legacy? Like the thing that I show you, it's a rough overview of like how the environment is done, but now we're going to go into the details of how each asset is done when it comes to like the traditional 3D modeling workflow for game engines, right? So let's go to the next slide, please. And yeah, we pretty much like that doesn't matter pretty much the workflow. We pretty much start with a blockout always. Then after the blockout, after we get the idea of the composition, the light, the basic, the scale, we get into the high poly part. That's where you saw the sculpting part. That's when we get into the details. And for that same asset, we do a retopology. And what do I mean with retopology? I was going to show you something in Blender, but whatever, I think we can explain it good enough. But basically, we do a asset, a pretty heavy asset with a lot of polygons, a lot of triangles, a lot of vertices, and each one of these vertices in the model, they represent a value for the computer, and that means that each one of these vertices, it's something that the computer has to pretty much render out, load. So the more polygons you have in a model, the heavier it is to render, and the worst time you're going to have trying to render it out in Unreal Engine, right? So the way we do things in like game development in general is that we grab that same model. Can you go to the next slide? I don't know if I had a like example. No, go to the other one. Sorry. Yeah, right there. No. So no, go back, I think. Back again. One more time. Okay. So we pretty much do a retopology. We grab the topology of the model of the high detail skull we got, and we pretty much simplify it. You can say it's a way of simplification. We simplify that model, and to the point that you only got like the basic form of the model. We pretty much destroy all the details on the model. That way, the model it's not that heavy. It's way easier for the engine to render it out, for the computer to load it, right? Then now you can go to the next slide, please. And then we grab both of the models and we pretty much do a bake process. We pretty much grab the high poly and we bake all the details of the high poly version into the low poly version. So we do this with a normal map. Now you can go to the next one. Basically, a normal map is a pretty much you can say it like a shader, and it's a way for game developers and just 3D artists in general to represent details when there's not any details in the topology, because something like there's two parts: the topology, the model itself, the shape, and the shader, the material, right? So with shader, with a material, we pretty much represent high details in or low poly modeling. So each of the colors in a normal map represent pretty much a direction. They represent X, Y, and Z depending on the color. You see above, you can see we have like the red color for the x-axis, the y for green, and for blue we got c-axis. That's why you see like a lot of purple and like green, and in the normal map below, almost every normal map looks like purple. That's because pretty much we are on a specific sea height, and yeah, it's pretty much the mix of the three colors: red, green, and blue. That's pretty much what you get. They are represented right there. So with this normal map, we can give all those details. For example, these circles can go into a plane surface, and they can actually we can actually have a lot of circles in our plane surface without the surface actually having the topology for it, right? So can we go back to the other? No, go back like the other one. Sorry. Yeah. So after that, we pretty much do the texturing, like I show you in the video, and then we pretty much bake the lights in Unreal Engine, and well, in game engines in general. The classic way for us, I was going to show you that in Unreal Engine because it's pretty easy, but yeah, we pretty much have the all models in the scenes, and instead of calculating daylight every single frame, we pretty much pre-calculate that. It's like a pre-render, but for the lights and the shadows. So we bake those lights, we bake the shadows, we bake the light into the assets. That way you don't have to actually load every single frame in every instance the light you're working on. So this is pretty much the traditional way of doing things. Let's go to the next slide. Next two slides. Yeah, the right there. Uh, so yeah, that's pretty much baking when it comes to normal maps. We do a high poly version. It's the detailed version. We do a low poly version. It's just the low poly one just has to have like the overall shape of the asset, but it doesn't need to have the actual details. And thanks to the projection, the baking of the normal maps, we pretty much end up with a asset that has the details of a higher quality assets, but without the actual topology. So that way, that's the best or the industry standard when it comes to video games, to or game engines in general, when it comes to saving high quality detail on a simpler asset. I wanted to show you. Let's see if the lights come back, but I want to show you at some point what I'm talking about when it comes to like the normal maps. That's something it's easier to see in Unreal Engine directly. Yeah, let's go to the next two slides. So yeah, in this example, you have one one model that actually is less detailed than the other one, but the reason they look alike is because even though one has actually less detail, is well because one has a normal map, and it's like a trick. You can maybe think the normal map as a trick to deceive the eye with shading, with shadows and light, to deceive the eye, so the eye thinks, or we think that it has more detail than what it actually has. Like I told you, I wanted to show you this in Unreal Engine. It's pretty easy to see, but yeah, let's do it later on or in tomorrow's class. So let's go to the next one. So yeah, this is an example of retopology. As you can see on the left, all the details are all the like the destruction of the asset, all the cavities actually have a shape, actually are there in the form. But on the right, you can actually see on the right that the topology is actually really simple. But thanks to normal maps and thanks to the baking of the general color and the normal maps, you can get the illusion that those details are still there, but the triangle counts and the vertices counts, it's way lower. It's way lower. On the left, you cannot even see like the texture of the asset because it has so much triangles that it's covering the wireframe is actually covering the texture. And on the right side, you can actually see the actual size of each one of the polygons or the triangles you see right there. See, so let's go to the next one. So that was everything I explained so far. That was the legacy way of doing high poly, like photorealistic assets, right? But when it comes to nowadays, but not for, we're going to talk about it. We're going to talk about the advantages and disadvantages of the legacy workflow or the classic way of doing things. And this is the new way of doing things. It's not for everyone. We're going to talk about that. But Nanite, it's basically Unreal Engines or Epic's solution or like new technology they got going on for the last, I don't know, like 6-7 years. Let's go to the next slide. Yeah, let's watch the video. Yeah, thank you. So this is a tech demo that was done like 6, 7 years ago already, something like that, at least 5 years ago, when Nanite came out, basically. And what Nanite is about, it's basically a new rendering technology that, depending on how close you are to your asset, it's how much detail is going to render out. So the closer you get to a rock, the more the more integrate detail you're gonna actually see. So it sounds great, right? Can we go like more into the video uh, after they like finish talking or something? A little bit more, maybe. Okay. So yeah. So I'm seeing it like in like 2 frames right now. So yeah, that's just probably me because I'm on data right now, phone data right now. But as you can see, like that's pretty much a simple touch demo, and you can actually see all the integrate details. It came me out. I don't know if you guys can hear me right now.
Yes, we can hear you.
Tell me if I hear me like with lag or something, because I'm running on phone data right now. Okay, so let me see if I can move myself to a better location for to get like better signal. Okay, so I think this is the best spot so far. Okay, so as you can see, the character overall in the video, you can see like the character getting really close up on the rocks, on the environment, and you can actually see all the cavities in the rocks, every single like cavity on the rocks. And that in video games, that's a pretty challenging thing to do at this level of quality that they're showcasing in the tech demo right now. Because Nana is a new cluster way of rendering stuff. Uh, the only thing, like the important thing you gotta get from Nana is that it helps. It's a fast way, a fast, easy way to get really high detail stuff, but it also saves us a lot of time in production because you actually skip a lot of the steps from the traditional way of like the baking and the normal maps. You actually skip all of that, and you get to a point where you basically the time difference for production for the assets is actually way less, because instead of doing like two versions for each asset, you actually just do the high poly and you throw it in Unreal Engine, and that's what you work on. And that gives us a lot of flexibility and time for assetting, 3D modeling assetting. So can we go to the next slide? Let me see, guys, if I can. The stream is like, yeah. Okay, so this is the 9-night workflow pretty much. Instead of being like 6 steps like the other traditional legacy workflow, it's only 3 steps. It's blocking, you do the high poly, you know, you do the sculpt, and you can actually throw in that high poly sculpt into texturing, and that model without optimization, without doing the, you know, the normal maps baking or anything, you can throw that directly into Unreal Engine. So we're talking about big time savings, because you're not doing two assets per two models per asset. You are actually just doing one, and that's the one you can throw in. So let's go to the next slide. Yeah, put on that video. Go to the the middle part of the video or something. Yeah. Yeah, so this is a tech demo that was released like 1 year or two ago, like 1 or 2 years ago. This is basically two things. This is showcasing Lumen and showcasing megalights. But let's talk about Lumen. Lumen, it's a pretty much a new way of like global illumination method. Instead of baking the lights, you know, instead of saving the lights and the shadows to memory, to a shadow map or something like that, we have virtual shadow maps, and they give us pretty much real dynamic ray trace global illumination. So I wanted to show you guys the museum project for this. But yeah, it's basically a new global illumination method for lighting in the Unreal Engine game engine. So it's a great new way of illuminating your scene in Unreal. So this saves us a lot of time, because instead of waiting for the computer to save all these shadows and lights into memory, they are doing this in real time. You know, the GPU is actually processing everything in real time as it is happening. So you can have, and we tested out this already in one of our Paramount commercials, virtual production commercials. We actually had a environment with like 100 lights or something like that, like 100 to 200 lights in one single shot, in one single scene. So we actually tested out Megalights, even though Megalights is in beta, and I think it is in beta still. We actually successfully used it in one of our virtual production commercials. So you can actually have a ton of light sources. And traditionally in video games, you gotta take well care of how many light sources you got in Unreal. The more light sources you got, even if you bake them, the heavier the scene, the render it's going to be. But with megalights, you pretty much can put like 100, 200, or I don't know how many more lights at the same time. And they can be like blinking on, they can be turning on and off, and they're gonna run just fine. This sounds like great, this sounds like perfect, but we're gonna talk about the disadvantages. But yeah, it's a new global illumination method that saves you a lot of time of baking the lights. Let's go to the next slide. Okay, so let's go to the next one. Let's do a comparison of the the benefits and the disadvantages. So the advantage of the traditional method that is on the left, even though you have to do more work, you have to do manual LODs, you have to deal with light maps, pre-baking light, baking normals, and really getting into every asset and optimizing every asset, that's something that takes a lot of time, but it's a great solution still nowadays, because the new solutions like Nanite and Lumen, when we're talking about real-time ray tracing, and this doesn't really matter if you're using Unreal, or if you're using Unity, or if you're using I don't know, Rockstar's game engine. Real-time ray tracing has a lot of noise when it comes to, shadows and light. In general, ray tracing, it's pretty noisy. It's really, really noisy. Real-time ray tracing is just pretty noisy. Real-time path tracing, which is the new gig, it's also pretty kind of noisy. We have, like, each year we're getting less and less noise, and we're getting Lumen updates, and we're getting there when it comes to visual quality. But that's something that you gotta take into account. When we talk to the guys at View Studio in LA, and I think some guys at Pixomondo, they always use pre-bake lighting. They don't use Nanite, they don't use Lumen, because it generates noise. And it's to the point that even if in the studio we have used Lumen and Nanite for some of the productions, it's true that sometimes we get complaints from the DP about noise. Like, you start looking into the details and in the shadows, and you see a lot of like noise in the shadows with Lumen and Nanite. That's one huge disadvantages when it comes to virtual production, because you really want to take care of all the little details in the visuals. So one huge advantages of like Lumen and Nanite, it's of course the time. It's easier to set up, it's faster, but it takes like less time. But yeah, you come up the trade-off that it has noise, and even if you try to your best to optimize your Lumen and Nanite scene nowadays, even if you use one of the newest 5.7 Unreal Engine versions, you're gonna end up with worse performance in general compared to doing it in the traditional way. Like, even if you don't throw in, the heaviest models into Nanite, even if you like try to decimate them or something, Nanite uses just more milliseconds per frame in every way compared to the traditional way. So let's go to the next slide. So yeah, here we talk about the noise, and we also got the temporal anti-aliasing artifacts. So we got temporal noise, and we got aliasing artifacts. So when you use Lumen and Nanite, you're gonna get a lot of these temporal anti-aliasing artifacts. You're gonna see a lot of like the fine lines in the edges of the models. You're gonna start in the fine details. You're gonna start seeing a lot of like jaw lines, like a chainsaw. You're gonna see some stairs, and that's basically aliasing basically artifacts in your image. So yeah, it has a huge disadvantages. That's why in like most productions, even nowadays, they just completely avoid using Lumen and Nanite, even with the newest updates. And some video games are already launching and have launched with Lumen and Nanite, but they even have a lot of stutter problems and a lot of frame drops problems here and there. At the end of the day, it's even if it has been like 5 or 6, 7 years, it's a new technology. It's something people is getting used to, and it has its drawbacks, right? So let's go to the next slide. So yeah, we got traditional workflow, Nanite and Lumen. If you're going for the best optimized stuff, I think the best solution, for example, if you're going to do a VR application for Quest 3 or to run in PC, but it's for virtual reality where you need a lot of frames per second, like the standard is something like 90 frames per second, you're gonna want to go with the traditional workflow. And for Nanite and Lumen, you want to go only for heavy PCs that or heavy workflows that actually handle it. Hold on, guys. Let me check something about the lights quickly. Yeah, so I'm back, guys. Sorry. Yeah, it seems like the lights are gonna be back in like an hour or like 2 hours, something like that. Yeah, but yeah, let's keep going. Let's go to the next one. Yeah, so it's the fidelity trade-off. So depending on what's your target, what's your point, it's pretty much the solution you want to give. If you really, for example, if you're in a, if you're in a production and the bad team has really, really, really low, like really low time, like a big time constraint, and if they have no time to actually bake everything out and they are really bottlenecking the time for the guys in virtual art department, sometimes it's fine to use Lumen, but you just gotta take care of the noise you're gonna get and just make sure your scene, like depending on the scene, if your scene, for example, has a lot of reflections, you're gonna get a lot of noise in those reflections, and you're gonna have a really hard time to remove those, to like all that noise in your scene. Like you're gonna have a really hard time trying to deal with it. If your scene doesn't have a lot of reflections, it's pretty simple. It doesn't have a lot of details. Maybe you can get away with activating Lumen, using it, and maybe no one is going to notice. We have used it a lot in a lot of our productions because we're talking about really, really big time constraints, like really low time, like environments in basically like 1, 2, 3 days, something like that, or like big changes in minutes. One of the benefits, if you guys are using Lumen and the if you guys don't have a really powerful computer for the server for the brain bar, you could, I don't know, you could change the lighting without baking with Lumen, and maybe if it looks right, the director or the DP is going to actually like having the capability of changing everything mid-production in the shooting day, right? So maybe it's something you guys want. Maybe if you guys have, in some cases we have had like the background like blur out with a lot of depth of field, and you don't notice all this noise that Lumen comes with. So maybe you can get away with it, you know? So it's not all that bad, really. So let's go to the next slide. So yeah, you guys have any questions regarding Lumen Nanite? I wanted to give you more examples, like live examples in Unreal Engine, but I guess we can do those tomorrow. Yeah, I don't know if you guys have like any more questions or any doubt or any recommendation, something you want to ask.
Any questions, guys? Okay. Let me remind you, for you that will attend Friday and Saturday, and I hope you can make it because it will be really fun. Over there in Creator Space, we have an amazing volumetric capture system with around more than 100 cameras, like 50K of resolution, 50, and it's capable of scanning actual Gaussian splatting video and also mesh video. So it's pretty awesome, Mike. So you should be there for sure. So yeah, and Stephen, I don't know if you're attending, hopefully, but we can have a couple of demos regarding that because it's related to this. It's of course a super scan camera over there. So sorry about that, Stephen. Soon enough, Stephen. Soon enough, we will meet.
Yeah,
Next time I'm back on the West Coast.
Yeah, for sure.
Next time we'll
So
do a partnership with a jet instead of the Maserati, and then we'll fly you in.
exactly, we have a couple of cars, a Maserati, a Corvette, Ferrari over there. So we will
Yeah.
have a lot of fun playing out with that.
1956 Corvette.
Exactly. So yeah, just because it's related to today's session, I wanted to mention that. And yeah, well, if you have any other questions, we will of course send you the session of today, the recording.
okay. So
Yes.
yeah, let's continue. We
Okay.
actually still got a lot more.
Okay.
We
Let's
can,
sorry.
guys, sorry if, the lights went off, whatever. So tomorrow, the examples that I was going to give, like today in the moment, we can move them to tomorrow, and it's actually fine because tomorrow we're actually going to keep seeing all the different content types you can make for the LED volume. So it has something to do. So it's fine if we move some of the examples to tomorrow. Let's go to the next slide, please. Uh, did we move to the next slide?
Yeah. Sorry.
Yeah, it's fine. Okay, so what you want to do always is to get like this infinite horizon effect in your wall. What I mean by this is that a lot of times people just they ask us like, oh no, I don't want to invest in virtual production, or I don't know if I had the money to invest or to buy a huge volume, right? They People always think that, oh no, I need a LED wall like the one in Mandalorian. If not, I cannot work. No, but that's not true. You can actually get away with a lot of perspective tricks here and there. So you can actually seem like displays your recording you're recording in is actually bigger than what it is. So let's go to the next slide, please. So yeah, this is a good example I like a lot from one article, one BTS I found online. As you can see the wall. You can see right there the end display, and you can see that thanks to the wall, even though it's not that big, you can actually get the sense of depth. It seems like the place is actually a bigger room than what it actually is. And that's part of the magic of forced perspective and virtual production in general. You can make it seem that the place you're in, it's bigger. So let's go to the next one. Yeah, play the video, please. Muted. Thank you. So yeah, that was one of the things with Lord Knows music video. This is the behind the scenes video, and even though the screen in Dallas it's the biggest screen I have seen in my life. We For the shots we barely use all the screen. We really didn't need that kind of scale for pretty much every single shot. I think there's only just one single shot at the end that you can see like half of the wall or something like that. But for all of these shots, you're actually using just like 4 meters long by 3 meters tall LED volume, right? You're not actually using all the stage. And for the most part, for most of the productions, we even had part of the screen just black out, just turn it off. So we didn't use it. We pretty much, it's a huge place, but we didn't had to use all of the volumes. As you can see, what it's been recorded in a space that it's manageable to like a 4 meters wide, 3 meters tall volume. So yeah, we didn't really need all that wall for that. And a lot of times, I mean, this is the biggest screen we have used, but we have got away with really tight 3 by 3 meters or even less walls in the past for some shots. So yeah, you don't actually need like these huge LED walls. You need a lot of tricks. You need good you need good physical art department, virtual art department, and a lot of forced perspective really to get this sense of depth and the sense of the big horizon on the distance. And yeah, you can also see that for a lot of the stuff in this video, the fire, a lot of the clouds, a lot of the lighting strikes, a lot of stuff is just they're just planes. They are not. It's a mix of 3D and 2D images, 2D alpha images, PNG alpha images. That's basically it for the most part. You don't actually need like everything for it to be 3D. You don't actually need to render everything with like complex geometry or simulations, BDB simulations or something. You can just you can even do the whole mountain if you want with a plain image, PNG alpha image. So if you want, that's something you can do also. So let's go to the next slide, please. So let's talk quickly. Well, let's explain what's 3D scanning in general, reconstruction, photogrammetry, and Gaussian planning. Let's go to the next slide. So let's talk about the basics of 3D scanning. Let's go to the next one. So 3D scanning is basically the process of analyzing, because there's different ways for that, a real world object. It can be your house, it can be a statue, it can be a banana, it can be a whole coffee shop. It can be any place, any asset, it can be anything you want. It's the process of analyzing that asset and converting it into a digital data, into a point cloud data. So let's talk about it. Let's go to the next slide and let's talk about the different processes for this. So the classic way of getting some real object into the digital world is to take pictures of it. This is the most classic way of doing it, because you can say it's the easiest way to understand it. But basically, you take pictures of your object. You take around a lot of pictures of your object. You process them with, I don't know, reality scan, 3D Sapphire, Metashape, and you then get a reconstruction of that same asset, of that same banana, of that same house or whatever in 3D. And you can do that also with LiDAR, with structure light. And there's a ton of methods to get going. Let's go to the next slide so you guys can see some diagrams. So photogrammetry is basically using photos, right? For photos, that's it, right? LiDAR uses lasers. These LiDAR lasers pretty much, they throw in a laser, and depending on the time it takes for this laser to go on and bounce off a surface, depending on the time it takes, the LiDAR scanner knows what's the distance between it and the surface it's hitting. So yeah, that's a way of scanning too. That's the most used way to scan stuff in engineer, in real estate, because they actually need like accurate um, millimetric or like micron level measurements of the stuff. And you can also use structural light. You can use pretty much a projected grid with deformation, but structural light that doesn't really, it's not used that much when it comes to scanning, at least in cinema. Let's go to the next slide. So yeah, the first step is you take photos. For example, here we have this statue. This is one of the first scans we did like 3 years ago or something, when we started learning about photogrammetry, before we started going into this rabbit hole of 3D scanning, because it's a huge rabbit hole. So yeah, first you take a lot of photos of your scan. Let's go to the next one. Then you throw these images into your favorite choice. I don't know, your favorite photogrammetry software or 3D reconstruction software. This one right here is Metashape, Agisoft Metashape. It's a great software. It's not that expensive. They got a permanent license for like $150 or something like that, or like $200. I don't remember. You can also use Reality Scan, which is free right now. You can also use 3D Sapphire. There's a lot of like scanning reconstruction software, and you throw those pictures you took into the software, and you get a 3D reconstruction, just like a full-on 3D model out of the photos you took. So let's go to the next one. So this was like 2-3 years ago, and this is the kind of detail we get with some basic photogrammetry workflow. And we also get the whole texture of the model, a pretty accurate 101 replica of our model. Let's go to the next one. Yeah, so this is our model in Unreal Engine 5 with a basic HDR backdrop. And as you can see, it pretty much looks like 101 from what it looks like in real life. It's a great way to use to get really good photorealistic results. Let's go to the next one. Here we have some renders of the final statue, some close-ups. Let's go to the next slide too. Oh yeah, Gabriel sent the images in the chat. Yeah, it's an actual prop that it was used in a Guillermo del Toro movie, Kronos movie. It's called. It's all like destroyed and all, but it's the actual prop that it was used in the movie. You can see it in the chat. So for photogrammetry, yeah, this is basically the workflow. Maybe it seems a little bit too much, but it's all the same. You take photos. You can use your DSLR camera. You can use your mirrorless camera. You can use your DJI drone if you want. You can use a expensive LiDAR scanner if you have the opportunity to. You can post-process the images to maybe, it's the same process of processing images for basic stuff. You can, recover some information from the highlights. Maybe something got overexposed, or recover information from the shadows even. So that's optional, but yeah, you can recover a lot of information from the photos if you took them in a raw file. So then you throw it in with one of the 3D mesh generation softwares, reconstruction softwares, I mean, Reality Scan, 3D Zephyr. We also got, I think, Substance Sampler from Adobe. Yeah, we got a lot of solutions. And depending on what you're scanning, a lot of times you're gonna need to do some cleanup, do some mesh cleanup. For this, we can use ZBrush, we can use Blender, you can use Maya, you can use 3D Max, anything you want. And then you can actually bake the textures. So you can actually get a normal map, you can actually do a low poly version, and then you throw it into your render engine. In this case, we throw it into Unreal Engine, but you can render it, use the same model in Blender, in 3D Max, in Maya, V-Ray, Redshift, whatever you want. So yeah, this is an overall overview of the photogrammetry workflow for that we use at the studio. This is basically our workflow at the studio right now for photogrammetry. You can also see on the left, we have a color palette. I don't know if you can see the color chart. So that color chart, we actually have it. I actually have it somewhere over here in the room. But basically that color chart. Yeah, sorry guys. So basically that color chart, we use it to pretty much take the pictures with it just for color references. So that way we actually get a one-on-one actual color in digital. So we have like a color references of how the white, red, blue, and all the colors look in real life. So that way we can maintain the same color quality as real life. So let's go to the next slide. So if you're using Nanite, you can actually skip the mesh cleanup process you saw before, and you can actually throw that scan pretty much directly from the software into Unreal Engine if you want, if you need to do it, because of rough time constraints or something, you can actually just do that. And that's one of the benefits of Nanite when it comes to dealing with photogrammetry 3D environments. and that gives you a lot of like speed, a lot of time, and it also gives you a lot of iteration capability because you can scan it, process it, throw it into Unreal Engine without cleaning or anything, or dealing with retopology or baking and stuff. And you can pretty much show the director or the production guys, look, like this is how it looks on the environment, without losing time doing the baking, the retopology, and all of that, and all of that. And imagine you do all of that, you throw in the asset, they see it, they don't like it, and you just lost a lot of time. So you can actually just throw it in Unreal. Unreal is going to render it just fine. It's going to handle well all that heavy high poly meshes, like all that cavities, and you can throw it in. They can see, oh yeah, I like how it looks. I can get an idea of it, and well, then you can actually retopology, optimize the asset. But yeah, you have that capability of you actually using Nanite for that. So let's go to the next slide. So yeah, photogrammetry is pretty accurate. You got a really metric accuracy. If you use LiDAR, you got even more accurate. But photogrammetry has a lot of problems. Let's go to the next slide. So yeah, we can get, this is the kind of level of detail we can get. This is a shoe I found somewhere, in the streets pretty much. This is a scan we made. And this was with a basic camera, with a basic like setup. And the image you're seeing right now, it's pretty much a render in Blender with with a light in Blender. And it's a pretty high integrate detail asset pretty quickly with a really basic setup. I pretty much grabbed the shoe, put it on a table, and I took photos around him, and this is the kind of detail you can get. So you can get pretty real photorealistic results really quickly, really easy if you want. Now you can actually take this kind of detail with your phone right now. Like if any one of the last generation's phones from iPhone, Samsung, Google, whatever it is you're using, anything above like 12 megapixels or something like that can get this level of detail we are seeing right now. It's an amazing level of detail. Maybe tomorrow I can show you like how integrate it gets. Like you can actually get the surface finish of the shoe. So let's go to the next slide. So yeah, you got questions so far? We still need to see Gaussian splatting. So yeah, I don't know if you got questions so far or anything. Okay, we are all good, right? Okay, so let's go to the next slide. We're almost done. So yeah, Gaussian splatting. This is the new guy on the block. Let's go to the next one. Gaussian splattings are pretty much doing a revolution in every single industry that uses photogrammetry, because photogrammetry gives you, at the end of the day, it gives you a mesh, like polygons in mesh, and the problem with meshes, or the problem with photogrammetry, is that if you try to scan a reflection or something that has a lot of reflections, the scan is going to break. You're not going to be able to scan that. If you try to scan fine detail hair, the human hair, like in detail, you're not going to be able to scan that too. So Gaussian splatting is a new way of like rendering. It's not using polygons at all. It's using splats. So let's go to the next slide so you can see what I'm talking about. So it's using a splat. It's not a polygon, it's a splat. And the splat has position information, it has color, and it has opacity, and it has its shapes and size. So that right there, you see in the image below, that's basically a splat. That's a yellow splat you're seeing right there. It's weird to explain, but it's this new form of like showing something. It's pretty similar. I will say it's pretty similar to like volumetric, how volumetric simulation are displayed. It's not the same, but I see it like as a pretty similar thing. Those are splats right there. You know, they not only polygons only have like position information and like shape and size, and that's all. And you can add color with textures, but you know, they have a rough time with transparency and stuff like that. And they're not as flexible as the splats. You know, splats can be any shape, form, and size. They're like this, you know, volumetric volume thing in the space. So yeah, it's not a mesh. And let's go to the next slide.
It says that I don't have permission to show this file.
Oh, click on the Danny Virutal name, please. Yeah. So this is a guy I knew online. Click on the B, please, on the B image. The one that is a B. In the left. Yeah, the B. Yeah.
This one or which one?
No, the B on the left. It's right next to the spider. It's right next to the spider.
Oh, sorry.
Yeah. So, honeybee, yeah. So this is a Gaussian splatting. This is a guy I know online. So yeah, as you can see, like it's amazing. He grabs insects and scan them, and this is a great benchmark for Gaussian splatting. Why? Why is this a great showcase of the power of Gaussian splatting? Well, because you got two things that photogrammetry classic legacy photogrammetry workflows cannot do. You got the fine hair details. As you can see, it captures every single hair strand detail perfectly. And in the backhand part of the honeybee, you can actually see the transparency, the whole texture of the flies, right? Of his wings. I don't know how to call them, sorry. But yeah, all this, like if you were to try and process this with a classic photogrammetry workflows, you're gonna get a broken mesh result, a really blob thing, and all those wings right there, all that detail, all the transparency effect, that reflection you see of the light hitting the wings, the fly wings, right? The reflections you even see in the eye of the honeybee, all that is going to be lost completely when it comes to photogrammetry. But Gaussian splatting can do this. And this is why Gaussian splatting is revolutionizing the way everyone is scanning right now. Not only in cinema, you know, for VFX, it's also revolutionizing the way we do real estate scans. It's also going to revolutionize the way we do preservation scans for museums. You know, imagine getting this level of detail and scans in every single, I don't know, nature science, you know, museum, or every old artifact, you know. shiny bases, shiny Roman Greek bases, old money from 1,000 years ago, old insects, all the insects, in the museums. You will get a real accurate representation of all of these assets, So let's go back to the presentation. So yeah, I really like that. It's a benchmark to showcase. It gives you a idea of how capable Gaussian splattings are. Yeah, let's go to the next slide. So yeah, this is a side-by-side comparison matrix. The problem with Gaussian splatting right now is that it's a new format completely. Its splats are harder to change, to handle than polygons. Polygons, you can move them around each vertices, and the splats, even though we already have technology to repaint actual splats, uh, there's harder. They are like harder to handle in general because they're like this transparent, ghosty thing. Like even to separate one splat from another, it's pretty hard. But one of the benefits is that it's actually a pretty optimized thing to render. You can actually let's go to the next slide. Oh, Luis, let's go to the next slide. Yeah, thank you. So yeah, this is the comparison. You know, um, to the other one. Sorry, the last one. Go back. No, go back. Go back. Back.
There or more back?
One more back, please. So yeah, with Gaussian splattings, you got unmatched detail. You got like all the hair and fuzziness. You got the live reflections, so you could actually scan metal parts without losing the reflections. You could actually scan mirrors if you want, which is kind of crazy. Um, so yeah, the problem is that it's harder to handle, it's harder to clean up, it has no collisions, it's harder to use for interactive stuff. But lately, there's already some solutions for all of this I'm talking. So the more Gaussian splattings have been in the market for like 2 years or 3 years max, something like that. The first Gaussian splatting scanning papers came out like 3 years ago or something like that. And everyone is using them, even in real estate tours, museum tours. It's just the benefits overweight completely the disadvantages it has right now. And even in Unreal Engine, you already got multiple plugins to support Gaussian splattings. So yeah, we're about to finish. Let's go to the next slide quickly. So this is the Gaussian splatting workflow. As you can see, it's pretty much the same stuff as the photogrammetry workflow. The only real thing you change is the processing of the images, because instead of using Metashape or reality scan, you use something like Jawset Photoshoot, or you use something like Super Splat, or I don't know the other names, like Superfield Splat, something like that. So there's a few contenders when it comes to processing Gaussian splatting, but those few contenders are really, really good. So yeah, let's go to the next slide. Can you go to the next slide, Luis, please? Yeah. So 3D scanning, it's costly and over complex when you try to scale it. And that's in general. Doesn't matter if you're trying to do photogrammetry or Gaussian splattings, even though you can get away with actually really great scans with with your camera and a tripod. You can actually do pretty great detailed scans nowadays because phones got these really, really great phones have this really great camera nowadays. Um, but when you try to scale it down, for example, to the rig they're using in Santa Monica, that the rig we're gonna have at the studio for the Friday and Saturday. When you try to have like multi-camera rigs, it can get pretty expensive pretty quickly. And when you try to get into, doing virtual tours for real estate or VFX, reconstructions of like big places of like whole streets with drones and portable lidar scanners like the X-Grids portal or some of the Apology real estate lidar scanners, they are not cheap at all, right? The point of entry is actually really low because everyone has a camera in their pocket. But to do the next big jump when it comes to scanning, you gotta spend thousand and it got me off for some reason. Do you hear me, guys?
Yes, we hear you.
Okay, so we're about to finish. Let's finish right here because I'm gonna talk about tomorrow. Cross polarization and content in general. We're gonna talk a little bit about advanced scanning techniques. We're gonna talk about all the different types of content you can make for your virtual production LED volume, from 2D images, 2D plates to 2D AI plates, and all the different new AI to 3D workflows. So yeah, let's leave it right here, guys, and let's continue tomorrow. And I don't know if you guys got any questions. I wish I had the lights to really show you some of the examples, but I can show them tomorrow, no problem.
Hey everyone, I also just want to jump in and welcome Faith here. She graduated from the Martin Scorsese virtual production program the first year. Welcome, welcome. Hello everyone. Hello Faith. So cool to have you here.
Thanks for having me. This is great.
You're going to be coming out to LA a lot more often, right?
Fingers crossed. Yeah, if I can make it work, I'll make it work.
Awesome, awesome. Yeah, this is Sebastian and Gabriel, and Mike is ex-ILM building some really new cool stuff, and Stephen here is here. You know Stephen, right? From the sales, and Alicia's here, and yeah, we're super excited you're here. You're welcome all the time. Welcome to the collab.
Thank
And
you.
this is
Welcome.
great. I'm looking into G-splatting right now, so this is like perfect timing as well.
Fantastic.
Well, that's great to hear. Yeah, so tomorrow we're going to talk about all these advanced techniques for scanning and all the types of content for you guys. Let me show you something I got here. Uh, so, I got a lot of equipment right here, but yeah, uh, scanning, the rabbit hole of scanning, it can get pretty expensive pretty quickly. even with like simple equipment like this little this big flash right here. It's a Godox 400 watts scanner. I use this for polarized 3D scanning. We're gonna talk about that tomorrow. But yeah, it can get pretty expensive pretty quickly. And I also have, I mean, I have all the scanning equipment right here. So yeah, I also got this little color X-ray chart. We use this to calibrate the actual, like I said in the presentation, use to calibrate the actual colors from like real life into digital. So the actual colors are like legit a good representation of the real thing, right? So even little stuff like this is like $100, and you have to change this like every 2 years or even less. So all the scanning equipment, even though everyone can use their phone, when you try to get into advanced workflows and really high-end productions, it gets pretty expensive pretty quickly. So yeah.
It was an amazing presentation. Really cool. I'm super excited for Friday and Saturday. So they're setting up the 50 panels right now. I keep getting texts from Manny at Creator Space, and then we can also pop over to Alexi's stage, which is a huge stage, and then Faith at Noah Katner's thing that we had at the Scorsese. We were partners in crime in the car during a car process. So Faith, we're going to have a collaboration with Maserati for this one, and then also like a 1956 Corvette. So we're gonna stream it, and so you and Steven, it would be really cool, and everybody here online. And Mike, you're coming. You're going to be there on Prem, right?
Yep, I'll be there.
Yeah. Cool. Yeah, it's gonna be a
Great.
lot of fun. So,
Beautiful.
and we hope to collab East Coast with you all. So, Faith, maybe you can host us somewhere where you and if you end up East Coast.
I can absolutely make that happen. Come on over.
Okay, so thank you guys. I don't know if anyone has any questions. The lights came back like 5 minutes ago.
Amazing.
Yeah, just in time, right? Yeah, this I ask my family here. Yeah, it seems like someone uh, crashed into a electric post, and they usually take like 2 to 3 hours to get the lights back. So yeah.
It wasn't me.
Thank you, guys. Thank you very much, and see you tomorrow. I will send you the recording of this tomorrow, as I did today. We did today. So, Stephen, so I will have to go. Okay, no problem, Steve. Good luck with that. Okay.
Oh,
Yeah,
good
thank you
luck.
very much.
Thank you very much, guys.
Great to hear. Bye, guys.
Awesome.
Thank you.
Bye,
Bye. See you
guys. Thank
tomorrow.
you.
See you tomorrow. Bye bye.
Bye.